Okay, can everyone hear me? Okay, let's continue with the second problem. First one. Okay, what answers did you get for the second question? Okay, good. 15 is the right answer. Ishan or Bharat, can you explain, one of you?
Yeah, this is Ishan.
Okay.
So first I wrote like A, B, C, D, E, F to represent the 6 people.
Mm-hmm.
Yeah. And then I paired up A with B, A with C, A with D, A with E, and A with F,
Mm-hmm.
which was 5.
Mm-hmm.
And then I did B with C, B with D, B with E, and B with F. And then if you do that, you get 5 plus 4 plus 3 plus 2 plus 1, which is 15.
Okay, good. That is the right answer. Although, let me see. So we want to count. What we're asked to count is actually this. So how many ways can we make them into 3 groups? So it's, for instance, we can make A, B, C, D, E, F. This is one choice, and then A, C, B, D, E, F, or A, C, B, E, D, F. So basically, we're asked for the number of these combinations. Pavan, for your question, what do you mean by does pairs mean there's 3 groups?
I got confused because I thought it was like groups of 3, so I did 6C3 instead of 6C2.
I see. Okay, no. So when they say, so each pair has to be a group of 2. So how many combinations of 3 pairs? So example is like what is shown here. So A, B, C, D, E, F, or you pair A and B together, C and D together, E and F together, or A and C together, B, D together, E, F together. So Lishan's way gives the right answer, but I think it might be coincidental in this case because when we're taking all possible of one pair, and but that doesn't necessarily mean that's covering all the possible pairing ups of all the people. So let's look at this. So so let's see. So I've written down some of them here. So any ideas of how we can count this?
$15 times 14 times 13.
How do you get 13 here? Okay, so let's think about first how we have 6 students, the A, B, C, D, E, F. We want to find, okay, how many choices are there for this first group of people? So I have 6 students. I can choose any 2 of them and make the first group. So that could be, so I have, this is what Ishan had computed. So we have A, B, A, C, A, D, A, E, A, F, B, C, B, D, and so on. So there's 15 choices for this first group. Now, we also have the number of ways of choosing the second group. So that's in the remaining, once I choose A, B, now I have 4 people left. I want to choose 2 from that 4 people. So that could be, let's say, C, D, C, E, C, F, D, E, D, F, E, F. So that's another 6. And now the last 2 people, once I have the first pair, the second pair, the last 2 have to be just themselves. So 2C2, that's 1. Okay, so now I'm counting the number of choices for the first group, the second group, and the third group. Is there anything I'm counting multiple times? So consider this case. The first group I pick AB, second group CD, the last group has to be EF. Is this the same thing as saying the first group being CD, second group being AB, third group being EF? So once I pair the students up, does the order matter? Here I'm saying, okay, there's 15 choices for the first group, 6 choices for the second group, and the last group is fixed. But if I picked AB as my first group and my second group as CD, versus CD as the first group and AB as the second, is that the same? Can everyone hear me?
Yes.
Okay. Okay, so these two are going to be the same thing, right? Because we're asked for how many different combinations of 3 pairs are possible. So if I pick AB as one group, CD as a second group, and EF as another group, it's the same thing as if I picked CD as the group first and then AB and then EF. I just care about how I pair up the students. So once I give you 3 pairs, how many different orderings can the 3 pairs appear in? So if I have groups 1, 2, and 3, is let's say 1 being AB, 2 being CD, EF, that could be 1, 2, 3, 1, 3, 2, 2, 1, 3, and so on. So there's 3 times 2 times 1, which is 6 orderings of the people or of the groups. So this product, 15 choices for the first one, 6 for the second, and 1 for the third, I have to divide it by 6. To account for, because I'm counting the groups multiple times if it's the same people just chosen in a different order. So this gives me 15. So it's a little bit coincidental here that this first term here of 15 was actually the final answer also. So Ishan's solution counted this, but you actually had to multiply by the second choice and then divide by the orderings. And in this case, they happen to be the same value, which gave 15. Does this make sense? Any questions? Okay, let's go to the third problem. Okay, I see a few different answers. This problem was harder than the others. 5 over 128 is correct. Pavan, can you explain?
Okay, so first, what we're gonna do, what I did was I found the number of ways where in eight blocks she went back home. So there's 2 to the 7th choices because the first thing is guaranteed. So we have 7 more. So 2 to the 7th ways to go. And then we know that it has to start with east east, because if it goes east west, she's already gonna go home.
Mm-hmm.
And we also know that there has to be a total of 4 east and 4 west because they have to cancel out essentially.
Yep.
And if you like experiment with this, you also realize that the ending has to be both be west west. And then if you just find the rest of the combinations, you find that there's 5 in there, or you can do that there's 4 choices in there and 2 of them repeating. So you do 4 factorial over 2 factorial times 2 factorial. that gives you 6, but you have to remember that if it goes east, east, west, west, then that doesn't work. So there's total of 5 choices.
Good. I think it's the opposite. West, west, east, east doesn't work. Yeah. Good. Yep. Okay. So let's go over what Pawan was explaining here, and let's think about this pictorially. So you have Gracie starts from this point. So Gracie starts from this house and moves 1 unit east. So she moves 1 block east. Now, from here, we know that she moves some blocks east, some blocks west, and the first time we want her to land back home is after 8 blocks. So 8 blocks means she had to move a total of, so 8, she's moved 8 times and ended up back home after the 8 blocks. The first one being east, there's 7 more steps she makes. So in the 7 steps, we know that 3 have to be east. So she went a total of 4 blocks east and 4 blocks west to reach back home. Just having this would have been easier, but the tricky part is that that's the first time she lands back home. So what does this mean? So I can't just say I have 7 steps. So it's like an E followed by 7 blanks. Some of them are E's, 3 of them are E's, and 4 are West. But it's not as simple as that because it can't just be East, West, so on. Because if I did East, West, I would have gone back home immediately. So it has to actually be East, East. And then the next one could be East, could be West. Basically, you have to make sure that I never have more, at any point, I should never have more West than East. Because, or as many West as East, because then I would reach back home. So this is why the first 2 have to be East. We also know that the last step that she makes, she had to go west, right? Because if she had gone east, that means she was east of her house to start off with. We know that her last step, she reaches back home. So if the last step she's reaching back home, she should have come west for that step. So west has to be the last option. Now let's think about, okay, the intermediate ones. What about the second to last one? Now, this also, she started off, so that means she's here and moved west as the last step. Now, the one before that, could she have moved east? If she moved east before she moved west, that means she was again at the house at the second to last step. So that means that the second to last one also has to be west. So this is good because we've covered most of the cases. So we know the 8 total steps. First 2 are east, first 2 are west. So there's 4 in the middle. And these 4 have to be 2 east and 2 west. So what are the possible choices? It could be east, east, west, west, east, west, east, west. East, west, west, east. West, east, east, west. Okay, so we have, these are the 6 possibilities. Now let's think about, do any of these cause her to reach home before the 8 steps? So let's think about them one by one. So east, so she starts off with 2 east, so 1 block, 2 blocks east. Then if we go by the first one, she goes east, east, west, west. West, west is the last 2 from here, so that works. So we can follow that for each of them. But let's think about the last one particularly, west to west, east, east. So she starts off going east and then east again. So she's 2 blocks away east from home. Now let's go west, 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 west. That reaches back home. So this case is actually not going to work because that means that at 4 blocks, after moving 4 blocks, she actually reaches back home. So this one doesn't work. But if you look at any of these first 5, they all worked fine. So 5 work. For the 5 possibilities for the steps she could have made. And we know that the total steps is basically 2 choices for each step for the 7 steps that she makes after that. So there's 2 to the 7 total possibilities. So 5 over 2 to the 7 is 5 over 128. So we count the total number of ways that she could actually reach back after 8 blocks without having reached home before that. And you divide it by the total number of steps she could have made. And that's 5 over 128. Does this make sense? Okay, so I also want to cover kind of an extension to this or maybe a simpler way of thinking about this in terms of instead of listing these out, is there any better way of counting these? Does anyone have any ideas?
So we would do, since there's 4 items, we do 4 factorial.
Mm-hmm.
And then we do over the number of repeating terms. So since we have 2 E's and 2 W's, we divide by 2 factorial times 2 factorial.
Okay, so this gives us the same 6 total, right? But the problem is it doesn't take into account, we don't want to include the ones where there's 2 west and then 2 east, right? There were too many west before east, right? So if I just count this, it counts all the possibilities, right? There's some extra constraint here that we don't want to exceed the number of east before, or it's the number of, we don't want to have more west than east at any point in our sequence, right? So is there a way to account for that instead of, so for instance, if this was larger, we might have to go through many of these combinations and remove them if they violate this condition. So yes, I agree. This will count the total number of so the 6 total, but then we have to go one by one to remove the ones that don't work. So do you know of any other way that we can actually count the subset more easily? Okay, so this problem can be, so I'll kind of define a similar problem. And that's saying if I have some parentheses, some are open parentheses and some are closing parentheses. How many ways are there to put 4 parentheses together? So we could have open, close, open, close, open, close. Let's say 3 open and 3 closed parentheses. So again, we have the same criteria, right? I can't open, close, close. This doesn't work, right? I need to have at least as many opens before I have that many closes. So you can think about it, if I have a counter, it increases for every open, it decreases for every close. It should never go negative, right? I can't close a parentheses that was never open to begin with. So essentially this problem is very similar to trying to count if I have parentheses that open and close, how many ways are there to create, to place the parentheses such that I never have more closes than opens. I can only close the ones that have already been opened. So there's this problem is actually related to something called Catalan numbers. But let's see a pictorial representation of how we can do this. So let me clear some of this so we have room. Okay, so let's put a grid on the board. Okay, let's. Okay, sorry, it's not a very even grid, but let's say, assume this is a 3 by 3 grid. Let's fix this. Okay, so we're going to answer, so we'll get back to the original question, but right now let's think about this slightly simpler question of, I want to set 3 pairs of parentheses. So 3 opens and 3 closes. How many orders can they be placed in? So open, close, open, close, open, close is 1. Open, 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 close, close, close. But of course, close, open wouldn't work, or open, close, close wouldn't work. Wouldn't work. Okay. So now let's think about this pictorially by thinking about what happens on this grid. So here, so the x-axis can be open parentheses. And this y-axis can be closed parentheses. So actually I can take each of these sequences, open, close, open, close, open, close, and kind of translate it to a path along this grid. So I can think about, okay, I did an open first, then a close, then an open, close, open, close. So each step I can move up, or I can move to the right, corresponding to I'm either open or close. Open, close, open, close. So I can imagine any of these parentheses combinations can be mapped to some path on this grid. So I can say I open a parentheses, I close, open, close, or open, open, close, close, open, close. So it's all the potential paths of 3 opens and 3 closes are going from this starting point of no parentheses to this point where I've used 3 opens and 3 closes. But the exact order in which that I traverse on this grid tells me which ones to open and which ones to close. So now we have this restriction. At no point can we have more opens or more closes than opens. What does that correspond to in this grid? What is the restriction in paths that is equivalent to this? No point can we have more closes than opens. Any ideas? So let's look at some of the paths that work. Open, close, open, close, open, close. Open, open, open. I open my 3 parentheses, close, close, close. What doesn't work? If I just try to close one, that doesn't work. If I open, close, now I can open and move this way, but I can't actually close and move this way. So what is kind of the constraint here on the paths that we're trying to take? There's some line that we can't cross. If we cross it, that means that it's not valid. What line is that? Any ideas? Okay, it's this diagonal line. So if I cross this diagonal line, that means that I had more closes than opens. If I stay on the bottom right of this diagonal line, any path that goes along this area works fine. So basically all I need to count is how many paths are there from this point to this point that never cross this line. So how do I do that? Now I'm trying to count paths that go either right or up at each step that go from this point to this point. Are there any ideas on how to count the number of paths? Okay, so we can do this, think about it step by step, and think about just starting from here. Let's say this is the starting point. How many paths are there to this point? Just one step to the right. How many paths are there here? This is just one open parentheses, right? So this is just one way. What about here? 2 steps to the right. This is just 2 open parentheses. So there's only one way to do that, or one way to get there. And what about the third one? 3 open parentheses. There's only one way to reach here. Now let's think about if I pick any other point, for instance, to reach here, right? To reach here, either I had to come here and move right, or I had to come here and move up. So that means how many places I had to reach here with 3 opens and 1 close, and my last one is a closing, or how many ways to reach here with 2 opens, 2 closes, and my last one will be an open. So basically at each point, I can think about the number of ways to reach this point is the number of ways to reach here, the left point, and just move right, or the one below it and move up. So the sum of these two is always this value here. So now let's think about, okay, how many ways are there to reach this point? This is 1 open and 1 close. So there's 1 way to reach here. And now we can just fill in the remaining following this idea. So we can just add up the number of ways to reach this point is this one plus this one. So this is 2. This is 3. This is 2. And this is 5. And this is also 5. So this trick of adding up the one to the left and one to the below and to the left being the total number of ways to reach each point would work even if we're thinking of paths on the whole grid. But here the constraint is we don't cross this line. So that's why we don't fill in the values here. We only fill in these values here. So it happens to be here that this problem of counting the number of parentheses with left and right is actually exactly the same as this problem. And you can think about it as equivalent if you just ignore the first east. Then the remaining ones, east and west, east is basically an open parentheses, and a west is a closed parentheses. We know that the first one had to be east, and the last one had to be west to reach back. And basically in between, we only want as many easts as wests. So for the 6 remaining steps between the first east and the last west, the number of ways to fill it is essentially the number of ways of going from this point in the grid to this without crossing this line. So if we do it in this way, we can easily go with, let's say, a 4x4. If I had to make 8 steps, I could just do the same thing and just compute the value in the grid here to see what the total number of ways is without having to write out all the options and seeing which ones don't cross this line. So effectively what we counted at first with the east and west was actually just counting the number of paths from here to here without crossing this line. So if you want to read more about this, these are called Catalan numbers. And there is some formulas to compute this, but I think this method should generally be sufficient. You can think about a grid and count the number of ways that you reach from one point to the other point without crossing the diagonal. Okay, are there any questions on this? So this is kind of a more advanced extension, but even if you understand how to list out the cases in this problem, that's also good enough to understand how to solve this. Any questions? Okay, that's it for today.
Okay, thank you, everyone. Hope you enjoyed the class. We'll see you next.
Thank you.
Yes, yes. Bye.
Thank you. Bye.
Bye.
Thank you.